Hello everyone, this is Bradley. This is the part 2 of the tutorial series talking about the similar kind of animation that you are watching right now. I improved this animation after the tutorial, and that's why it may look different compared to what you have seen in part 1. Also, to mention that this animation is in the reference to a post on Instagram using Blender and animation nodes. All details are in the descriptions, and if you have any questions, please leave the comment below. So let's start. The whole principle of animating this entire whole thing is based on the matrices that we assigned them. And you can see we have two groups of matrices. In the first part, the first matrices we are doing them is to make sure that all objects goes to the same grid. But later we're going to change the matrices separately so that the different group can have a different behavior. So let's just show an example about the offset matrices. And let's put the offset matrices into place. And by changing its translation, then I'm only moving our blocks to the top without affecting the booleans. And by changing this for, we can decide whether it goes up and down. And here I'm having a control. And I also put a trigger systems to this entire collection. So let's disable the blocks and the booleans. I also have a trigger system to this entire system, so that when our controller changes the location, scale, and the rotation ruler, it will update the trees. As you can see, the number is changing, which means the execution time of these node trees. And let's take an object controller for. I think I'm going to save files because I don't want to crash the computer. I don't know why, but my computer is very weak and it becomes weaker these days. I'm going to change the type to directional, change the X, and you can see by changing its X, now they are having different behavior. And if you're increasing the size, it means you're increasing the softness of our fall, which means it's just like you're spacing around the keyframes up to be farther away so that you have a more easy movement. And this is basically how it works. So you can even increase its size. I think usually 6 is good enough in this case. It depends on how you would like to animate that, but this is it. One thing to be aware that there is interpolation. So you can take that back, so the movement will be more kind of jumpy or more wavy. You can also try the other interpolation, but I think the back is probably work the most better. Sometimes you don't know what this interpolation actually looks like. So let's take an interpolation input. And hit W goes to viewer. So you can see the interpolation. So let's change that back. And you can see how it looks like. And the changing in that and so on. So basically this is a way to work that. Of course you can also change the curve interpolation. You can make an interpolation for yourself. But I'm lazy, so I'm just going to do with the default. I think at some level it's good enough. You can also use the elastic at some moment, but you can see how it looks. It's kind of very jumpy. In this case, probably not something I like. But the bouncy is maybe also something very nice. Sometimes you can also mix mix interpolation. So just mix two types of interpolation. You can play around with more about that. I have some presets that's like overshoot. So basically it's just like this, a combination between sigmoidal and the elasticity and whatever. You can change the position to change its effect and so on. Something like that, you can play around with these kind of things. Basically, in essence, this is a group node. In terms of preset, you can know more from the preset basics. I'm not going to detail about this. I think this is it. And the rest is about just creating more offset matrices, more for and other things. Yeah, basically it's all about it. Also one thing that's because I try to have the same spacing between the controller. So let's take a distributed matrices. This is probably a dumb method because I don't actually know. So let's take, I'm only going to take the X division, and you can take a look with, so let's hide everything. And you can see our vectors, the generated. And I'm going to change the type into step, and it only matters with the X distance. So now I assign with a kind of position. You can decide whether it's offsetted or not, but you get kind of idea. And then I'm going to take objects matrix object matrix output. I'm going to input the collection info and then put everything into control. So we have the controller, right? So I'm going to duplicate controller several times and put the objects into the objects, put the matrix into the place. So now we have different controllers in sequential order. Make sure the division is the same as the original. So put the all objects into the X division so we get a list length from object. So the amount of object will be amount of matrices you produce, so that each object goes to different locations. And again, you can decide whether it's offsetted or not. I'm going to change the -5, -6. And by using this method, you can make a sequential group of controller that has the same whatever stuff. And I think this is a kind of very nice way. And I want to change the size because now their size has been reset back to 1. So let's change the offset matrices. In size, I'm going to take a vector from values. I'm going to change that to 6. So now they overlap too much. Let's -9, -15, 12. So you get how it works. Okay. And the reason I'm doing that is because now I have a sequential evolve that I can apply different effects onto each of this entire series. So for one, I put the objects. So for one, I put the controllers, and for the other, I may put a controller second for the fall backings. And in this sense, I'm not going to play with translation. I would like to play with rotations. So put the rotations and probably also the scale. In the scale, I think I will do something different. So let's do this. And basically, this is kind of idea. Let's just show you how rotation and scales will essentially work. So firstly, I would like to discuss how to actually move this controller, because now the position of this controller actually has been assigned with all these matrices. So it's no longer keyframeable. It will cause a conflict between the animation node and the actual data. So essentially everything will, the animation node will override the keyframes that you set and so on. So to do that, I'm going to take a new empty called arrows, and then I'm going to take a transform matrix and put the objects matrix input, select our new empty, and to the transform. And once we do that, because this empty cannot be in the control, so let's just empty and copy and paste our triggers to the place, so that now basically the entire series of controller has been parented to the empty, so that I can move or even keyframe this empty so that I move this entire series of the object, which is kind of very cool. And now you can see our second valve is in its place. And you can simply justify change this rotation so that all objects will be rotated. You can also change its random rotation, and the specific part I will talk about later. So here, one thing you realize is that because we basically copied our initial object to the place, this entire setup has no random rotation, which makes it kind of very boring. Wait, let's firstly take the, so let's firstly just take a Alt G to the initial place. Let's keyframe that. So we start from the negative 14 and end as 14 actually more. So keyframe that. The third place. So let's firstly just use 3/4. So let's delete 1. Or actually I'll keep that, but just to be aware that the 4/4 maybe not used at this moment. It depends on how many setup you would like to play with. It's okay, does not really matter. Okay, up to this moment this is fine. The next step is about, yes, the random rotation of all these objects. So now you can see the pattern is kind of boring because we copy the initial object. So the orientation of our plane must be 90 degrees, must be horizontal. But I also would like to have the vertical plane being set. In this case, let's just add another matrix. I'm going to change the type to rotation. And because we want to synchronize the entire whole setup, so we make entire things. Okay. So let's take also a frame so that we know what they are actually doing. Sometimes it's confusing. To get a random rotation, I either want them to not rotate or rotate 90 degrees. So here, I'm not going to use a random ruler or similar kind of method because it will generate like 30 degree, 60 degree, and something like that. So I'm not going to use this kind of method. Instead, I'm going to use a random number method. And I'm going to create a list, put the list length to the count. And then I'm going to take a clamp and put the numbers into values. And I'm going to take a switch. The switch cannot receive multiple inputs. So I'm going to generate a loop. So here, let's directly put the float into the condition. And if it's true, then it will rotate 90 degrees. Otherwise, it will not rotate. And put an output. I'm going to output the ruler list. And before that, I'm going to combine ruler and rotate on the axis. Use degrees and output the ruler. So what? Just briefly explain what actually happens here. So a Boolean list is basically true or false, yes or no, check or uncheck, like check or uncheck. And the in terms of a number is basically 0 and not 0. So if it's true, then it's 0. If it's false, then it's not 0. So basically, this is kind of idea. And if you just keep the random number like this, like keep it 0 and 1, then you will realize, like keep the random number at 0 and 1, you will realize the chance to get a perfect 0 is very minimal, almost negligible. You probably will never get a 0. So which means you'll probably never rotate that. But by clamping that to, by changing that to -1, you also get a minimal chance to get 0 because even the negative number is still not 0. So you don't never get a true. But by clamping that, then you basically 50% of the number generated from this random number will be 0. And then you get a 50/50 chance to get whether it rotates 90 degrees or whether it's not rotating 90 degrees. And you can confirm that by goes to viewer. So that you can see there's lots of 0, but also not of 90 degrees. And by connecting this Euler list to rotation, then you get a randomness of whether it's 90 degrees or not 90 degrees, which is very nice at this moment. I think this is good. Let's rename this Euler list. So in this Euler list, I'm going to change that to initial rotation, so that we know what we're outputting. Here I'm going to use the same random number and the same clamp to generate another kind of rotations for the fall off. So in this case, I'm going to simply just name another switch, but this time if it's false, then it will rotate in other direction. Put the Eulers, and I'm going to name that as a animate rotation. And you can put the animated rotation to the rotation. Just to be aware, whatever you're doing, you must have the same sets or the same copies. On the other side. So basically this should be a copy. So random rotation, and we can put a frames. Just copy a frame and put them into frame. And let's call that animate rotation. So now you basically get a kind of ideas about how it works. You can also organize the tree better. I'm going to not change the rotation to back, but the sigmoid. Another thing we're going to do is the size. Just to say, the size is basically the scale. And I'm going to duplicate the same one. And the size, I'm going to change that to 0. And immediately I'm doing that, everything has been disappeared. This is not what we want, but I'm going to change the fall. I don't want to use an additional fall for such kind of function, because I want to scale them while the rotation and so on. So to do that, it's actually very easy. You just put the same directional fall to the place. But here you realize it does not recover. This is because if the fall is 1, or our object is within the fall, then the scales will be 0. What I want is they should start as 1, and they shrink its size a little bit, and then they recover back to 1. To do that, I'm going to change the setup here. So I'm going to change everything to linear. And I'm going to put the fall off into animated rotation. Here what I'm going to do is I'm going to interpolate these two fall off differently. So when we can interpolate the fall off. For one, I'm going to interpolate the sigmoid. For the other, I'm going to interpolate differently. There's a node which is called a mirror. So you can change that type to sigmoid, and change the interpolation. You can see how it actually works. So it goes to maximum, but it goes back to the initial state, and you can change its interpolation. So I'm going to put this mirror to the place. So now everything has been recovered at the end, and this is how it essentially works. So we finished the rotation. So let's organize this tree better, because it's already kind of messy. One thing I have to really remind you is that in this loop input, you can hit N and go to advanced setting and rotate, switch the up and down of these two outputs. Be aware that normal methods in the subprogram does actually not work for such kind of functions. So this is it. So you can organize these tree better. So there are lots of two things that I would like to mention. One thing is to change its colors, change the color of each object individually. I'm going to use a preset that I've built in my shader motion graphics tutorial. If you don't know about this preset, I highly recommend you to take a look at what's that. In the tutorial, I think I've built a object shader loop in example 2, so you can take a look to that. You can either go to the right upper corner or go to the link in the description to find these presets. Please really read the breakdown in the comments for that tutorial so that you go to the place where we build this preset right away. And you can directly put this object into object socket. However, for some reasons, the time to execute the node tree will be extensively increased, and it's hard to say why exactly. But there's one way to solve that. Instead, using this preset within this loop, so I'm going to output this loop with object list. And now I'm going to generate another loop for our preset. So you just hit W, goes to right, and remember to put the objects into objects, and so on. So now you can see the time of the execution of the node tree has not been increased very much. And certainly you can do this to make another preset where I did to make a object shader list. This version is basically a loop node version where you can receive multiple inputs for the socket. If you don't have the loop, then the list just do not go straight into the object socket because it only receives one object at a time. But within the loop, you solve this problem. And basically, yeah, this is it. So within this preset, I'm going to put the object into place. And the next thing I need to do is to add a vertex color to all of my objects. And here, another thing you can potentially see is within these instances, they do not have vertex color updated. In this case, you just rehit this deep copy. So now not all these instances have a vertex color. And you also realize they actually do not have a material yet. I'm not going to add materials and re-update the entire thing again. I'm just going to add the materials with animation node. So you can take a object material output. And this node also does not receive a list input. So I put everything into a loop and generate a preset which is called object material. It's just a version within the loop, so there's nothing special. So put the object list and take a material. I'm going to copy that and put another material. So now one has material and one has the other has material 001. So let's go to material. I'm going to activate use nodes. I'm going to call that blocks. And then I'm going to call a vertex color. I'm going to set the type into color and mix RGB. The entire theories of making it working has been explained into shader motion graphics tutorial as well. So I'm not going too much details about these things. But basically just put the colors into that. You can see instantaneously the color has been changed. And then I'm going to paint these panels. I'm going to go to objects and set another material. I'm going to rename that as Boolean. Basically just copy and paste and put the colors into. I'm going to reverse the colors and the other goes to the blue. So now they have an opposite colors. You can definitely play with them and so on. And the important thing is that you can use the FOV to control their colors separately. And this is very important with this deep copy option, and you do not find it in earlier version in Animation Node. It was proposed by me and fixed by Omar and the other developers. So you get a kind of idea. This is very important. If you don't have this deep copy, then it will actually not really work. You can test it by yourself, but anyway. And within this FOV, I'm simply just going to use object controller FOV. I think you can take the object too. And put the FOV into FOV. And you can see there's a transition of blue and red. And let's change that to directional FOV and put that to X. So now you can see the transition is kind of sharp. I think the scale, the animated scale, is kind of ugly when they all disappear. So let's take a vector from value and put the place to the scale. Let's name that to 0.5. So now you can see the transition. And if you would like to have a transition sharper, you just make the FOV sharper, like turn that to circular. Circular is kind of very sharp. Or you can make your own FOV. It's with a curve interpolation. As I mentioned earlier, they are all possible. Also, what's possible is just to decrease the size of the FOV, and you can potentially decrease that to -6, so they makes closer and so on. You can play with everything. You can play with everything. These are all doables. Just play around with these things. You get a kind of idea. And next topic is about how to make it a loop. Within the original post, you can realize there is some color transition which has been only limited to the middle of it's basically a line. So you change that to blue, but later you recover that to red. And to make this animation loop, you make our blocks move up, but you also move that down later. So how to do this kind of looping within our setup? So firstly, it's definitely possible to just make another offset matrices and make it move down and with another FOV. This is doable. The only side effect is just you add more spaghettis into your node tree, which may or may not be preferred. But more importantly, the issue is that for this object shade list, if you make it to series, like you take another object list, you can see the number of the time to execute this node tree has been dramatically increased. And if you activate more colors, more layers, it will make the stress of your machine very huge. And this might not be preferred if you don't have a good computer. Especially, I'm not having good computer, so I probably cannot handle that stress very much. So I'm going to just tell you a kind of trick to subtract the FOV. There's a node which is called a mixed FOV. This node, however, does not have a subtract FOV at this moment yet. It has been proposed by me, but it hasn't been done yet. So unfortunately, so you only have add, multiply, max, and minimum. But we're going to do something that to mimic such kind of effect by using this minimum option. So let's put the original FOV to A. And since the B is always 1 in this case, so what actually controls this mixed FOV is always the 2. So there's nothing changed. But if you decrease the B, then everything will be decided by B, because the FOV is already 1 and so on. And you can put another FOV into the place. Let's change that to FOV 3 and put this FOV into place. You can see now because FOV 3 is always comes later compared to FOV 2, so its value must be always smaller than FOV 2. But here we're going to just to invert that. So you can either hit this invert button or you just invert its direction. So now there's an overlapping between FOV 2 and 3 that allows them to give a FOV value which is 1. And the rest will be 0. So there's no color transition outside. So this is one way to do that, to do this kind of color transition which only applies to middle. And the good part of this method is definitely you're not generating one more shaded list node, so that the execution time has not been dramatically increased. Also, it's just 2 nodes compared to others more spaghettis. So I think it's definitely much nicer option for you to do. And this mix FOV method will definitely apply to all these offset matrices as well. So like you can put a mix FOV to our initial translation, and let's duplicate that and select our FOV 3. And let's invert its direction. Try to see, and then you can see it's actually already working. So it moves up initially with the FOV 1, but later it also moves down with the FOV 3. So this method can make your life much easier compared to generating another offset matrices, another FOV, and then another translation, and so on. It makes it much procedural, because if you would like to change the heights here, you also need to change the height later. But now you just change the height to 5 anything. You can. It's completely procedural. It just makes your life better. So this mixed FOV, it makes your life better. And this is basically everything that I can say. Later, it's just about a matter about how to change the random seed, to change the rotations, increase the number of instances, change the selection of your blocks and the booleans, and change the rotations. There are many different ways to play with that. So it's just a moment that you need to consider about your creativity with the entire setup and so on. And definitely you can increase another shaded list, another vertex color, and the stacking the mixed RGB node. These are all doable. So that's it. I think I've really finished here. So I hope you enjoyed this tutorial, and I'll probably see you next time. Bye bye.